All right, let's get going. We're going to start 4.3, and then we'll go back to 5.2. Okay. So let's look at 4.3. Let's clear the board. All right, good. Okay, so section 4.3, sorry. Solve linear equations by elimination. Some people will call it addition. So I'll go back and forth. I'll call elimination, I'll call it addition. It's the same technique. Okay. Let's this up like that. Okay. Now, so let's look at this puppy. Let's do a problem similar to what we did yesterday. Let's see, what's a good one? There we go. Let's do problem. Yeah, that's a good one. All right. So let's get back to this one right here. I have x minus 4y is equal to negative 14, and then minus 4x minus 4y is equal to minus 4. So we did this problem yesterday, and what we're going to do right now is we're going to sort of review what we did yesterday. So what I'm going to do here is I'm going to solve by substitution. And we said that when we solve by substitution, what we're supposed to do is we're supposed to isolate a variable. So let's isolate something. Let's isolate this one right here. So I went from x minus 4y is equal to negative 14. And I would bring the 4x to the other side. I'm sorry, 4y to the other side. And I would end up getting a x is equal to 4y minus 14. And once we isolate it, we would then substitute it into the other line. So in this case, we would substitute it into this one. So we would take this value here, and we would put it in here, and I would get minus 4. And anywhere there was a variable, I would put a parenthesis. And then we would put this in here. You would get 4y minus 14. And then we would solve for y. Plus 56 minus 4 is equal to minus 4. We would get y. Minus 20y is equal to plus 56 is equal to minus 4. Minus 20y is equal to 60, or minus 60. And then y is equal to 3, and that would give me my one answer. Okay, so let me give people a second to breathe. I did that pretty fast. Okay, but it's what we did yesterday. So if you want to copy, you can copy. But just know that this was the very first question that we did yesterday. So let's remember what the goal of substitution is. Our goal was to isolate one of these and then plug it into the other line. The reason why is once we did that, once we did the actual substitution, over here I have 2 variables and over here I have only 1. Once I have 1 variable, I can actually solve for that 1 variable. Okay. Now, after we finished that, we said, let's plug this in to one of the equations that has 2 variables. So in this case, I'm just going to plug it in here. And then we have y is equal to 3. Okay. So now we have x minus 4 times 3 is equal to minus 14. X minus 12 is equal to minus 14. And if I add 12 to both sides, we have x is equal to negative 2. So then our answer ultimately is negative 2 comma 3. Okay. Now for everyone who has just come in late, don't stress out. I repeated the very first question I did yesterday because I want to contrast it with what we're going to do new today. So if you are like struggling to like catch up and copy, the only part you need to copy is this part right here, this center part. Don't worry about this part. You already have this in your notes. Okay, so now this is done. Okay. Well, let me give everyone one more second to copy. Okay, so now this problem is done. Now what we're going to do is we're going to redo the exact same problem, but we're going to use a new technique. Okay, so we're going to solve by addition or solve by elimination. Solving by addition and elimination are exactly the same thing, and we're going to start with the exact same problem. Okay. Now addition, explaining this is easier after I actually do it. So rather than trying to garble some kind of explanation, I'm just going to do something. And then if you ask me why, I'll just say magic. Then after we finish, I'll go backwards and tell you my logic. Right? So over the weekend, I climbed the Himalayas, climbed to the top of the Himalayas to go to this temple of Kung Fu. And I went there and I saw the golden one. And I asked the guy, what's the secret to life? And he told me, multiply by 4. Okay. So what I'm going to do is I'm going to multiply this first equation by 4 because that's what the yogi told me to do. I'm going to multiply the top part by 4. Right. So the only thing I'm going to do is I'm going to multiply this one by 4. Okay. Now what will happen is that I'll multiply it by 4. This is exactly the same. And then what I'm going to do is I'm going to add up these columns. So when I add up this column here, this 4x minus 4x, this will then cancel, and I will get like that. And then I'll get y is equal to 3. Okay, so let's talk about this, right? So over here we have y equal to 3. Over here we have y equal to 3. Over here I did a substitution so I can get rid of my x's. Okay. Now over here I have the option. What I want to do is be able to add a column so that one of the variables will disappear. So when I add these two, I would get minus 3x. So before I add them, I have to make sure that these two numbers match. So I multiply this whole row by 4 so that I would get a 4x, and when I added them, they would disappear. Okay? And then we end up getting the same y value. Now, what I could have done is I could have multiplied this one by minus 1, and I could have gotten rid of the y's. Or I could have multiplied this by minus 1, make that a positive 4y, and then I could have gotten rid of the y's. So your goal is to make one of these variables disappear by making one of these a positive number and one of these the exact same number but negative. Okay. Now, once you do that, you then do the same thing. The way I find my x is exactly the same as what I did over here. I plug this into any equation that has 2 variables. Let me give people a chance to copy. Does anyone have a question? Now, in general, people tend to like this technique better. Be able to do both. On the exam, I'll let you choose. So even though on the exam it will say solve by addition, solve by substitution, you use whatever technique you like. Sometimes, usually this one is easier, but once in a while this is easier, which is why you want to know how to do both. Right, so I'm going to leave that up, right, for those of you who are copying. Some of you are a little bit lost and are shy to ask questions. So I'm going to put up a question so you can just sort of look at and think about what you want to do in terms of this first step. Okay. So let me give you this one. Is that the one I want to give you? Okay. Let me see. Yeah. Okay. X plus 5. Oh, I'm sorry. Okay, so let's solve this problem. Now think about what you want to multiply this row by so you can get rid of, so these two things add and then the x's disappear. Okay, so over here, I wanted to have this situation where this was a positive, this was a negative of the same number. So when I add them, they would cancel out. So what I'm going to do in this case is I'm going to multiply this one by negative 3, because negative 3 times positive 3 will cancel each other out. So what I wanted to happen is I wanted this to be a negative, I wanted this to be a positive, and when I add them together, they cancel each other out. So go ahead and add up the rows. So add that row, and add that row. Okay. So now you have 11y is equal to minus 11. So, and then you have y is equal to negative 1. All right. So now go ahead and plug this into any of these equations that has two variables.
Professor,
Go ahead.
isn't it negative 11y?
Oh, you're right.
Yeah.
Thank you. Then that'll be positive 1. Thank you. Okay. So go ahead and plug this into any equation that has two variables. So you can plug it into here, 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 or here. So try solving this problem. I'm going to plug it into here. Okay, so solve that problem. So over here I'm getting x plus 5 times 1 is equal to 3. X plus 5 is equal to 3. And then when I subtract 5 from both sides, I'm getting x is equal to negative 2. And now I have negative 2 comma 1. Let's take a picture of this. Okay, so let's try another one. Let's try. Okay, so let's try this one. Now, just know that you can get rid of either the x's or the y. It doesn't have to be just the x's. Let's see, let's try number 5. 5 looks good. All right, so let's try this one. Okay. Okay, now, well, actually, let me give everyone a minute to copy, because this is kind of a lot to copy, okay? And then we'll work on this next one. Okay. Now, let's look at this one over here. Over here, I could multiply this by -3, and then we have a situation where they cancel. Now, the problem with this one is that I can't multiply anything by 2 and get 3, and I can't multiply anything by 4 and get 5. Well, you could, but you'd be multiplying a fraction. Now, what we can do is think about what is the smallest number that these two meet at. So if I look at 2 and 3 and I count by 2s, 2, 4, 6, 8, and then count by 3s, 3, 6, I could make both of these a 6, and then they would cancel each other out, right? Make one of a positive 6, make one of them a -6. In the same way, I can look 5 and 4, and I can go 5, 10, 15, count by 5s, and then count by 4s, 4, 8, 12, 16, 20, and I can see that they both meet at 20. So I have an option. I can multiply this by 2, multiply this by -3. I can multiply this one by 4, and I can multiply this one by 5. Now, normally I pick the smaller numbers, but in the last example, the last two examples, I got rid of the x's, and I want you to have an example where I get rid of the y's. So we're going to do this one, where we're going to turn this one into -20, and we're going to turn this one into 20. Okay, and then that way they'll cancel each other out. So let's recopy this. Okay. Now I'm going to multiply this one by 4, and multiply this one by 5. So go ahead and do that. Okay, go ahead and distribute it, and you'll see that you'll get a -20 here and a 20 here. Add them together and cancel out the y's. Okay, so I'm going to get 12x minus 20y is equal to 56. And I'm going to get 10x plus 20y is equal to 10. Now, when I add them in their columns, I should get 22x is equal to 66. So x is equal to 3. Okay. Now, plug this into any of the equations that have two variables. So now this goes to here. Okay, so let's say we have solve 3x minus 5y is equal to 14. Well, not solve. And then we have x is equal to 3. Okay, so we're going to try to solve that problem. So we'll put 3 into here. Is that right? Did I do something wrong? I feel like I did something wrong. Give me 1 second to double check myself. I don't think you're supposed to get a fraction on this one. I might have something wrong. Let me double check myself. Let's see. Is that correct?
Yeah.
All right. Maybe I copied the wrong problem from the original. Okay. So now I'm going to subtract 9 from both of these. And I'll get minus 5y is equal to, oh, I did, it works out. Y is equal to negative 1. So now I get 3 comma negative 1. Okay, now, the next thing I want to do is work on something that has fractions. And then if you go, would that be on the test? And the answer is yeah. I want you to deal with fractions. It's something that comes up in pre-calculus and calculus, so we might as well just deal with it here. Okay, so let's try this problem. Well, actually, let me take a picture first. Okay, so I have a half x plus 1/4 y is equal to negative 1 over 12. Then I have 1/5 x minus 1/2 y is equal to negative 7 over 30. Okay. All right. So there's a lot of suck in this. Like, this sucks. I hate fractions. But what you want to do is you want to multiply everything, each row by the lowest common denominator to get rid of the fractions. So let me write that down. Multiply each row by lowest common denominator to get rid of fractions. Okay. So let's review how to get the lowest common denominator. So when I'm looking at this row right here, I have 2, I have 4, and I have 12. Okay. Now, for some of you, you'll just see it. And for those of you, God bless you, go ahead and do that. For the rest of you, break this down into prime factors. 4 is equal to 2 times 2, and 12 is equal to 6 times 2, but 6 isn't prime, so then 6 is equal to 2 times 3. Let people get a second to catch up and ask questions if they have it. Okay. So you go, okay, so 12 turns out to be our lowest common denominator. Okay. Now the reason why I'm showing this way to you is because in a few chapters, we're going to be doing this over and over and over again. So I want you to get the idea that 12 is made up of a bunch of prime numbers. 4 is equal to a bunch of prime numbers. And the way that you find the lowest common denominator is you find what factors are in all of these. Okay, so we have that. Okay. So go ahead and do 5. 5 is equal to what? 2 is equal to what? And then do 30. And see if you can find the lowest common denominator here. Okay, so let's look at this. So this is 5. This is equal to 2, and 30 is equal to 6 times 5, 2 times 3. So I get 5 times 2 times 3. So we're missing a 2 and a 3 here, a 5 and a 3 here. So our lowest common denominator is 30. So let's rewrite this. So we have a half x plus a fourth of a y equal to minus 1 over 12. And we're going to multiply each one of these by 12. Because we figured out that that was the lowest common denominator for this. Over here, the lowest common denominator was 30. And then let's do the division. Okay. Oh, this x is on top, sorry. Okay. 12 divided by 2 is 6. 12 divided by 4 is 3. 12 divided by 12, we just cancel. 30 divided by 5 is 6. 30 divided by 2 is 15. And then 30 divided by 30, they just cancel. And now I have 6x plus 3y is equal to minus 1. And I have 6x minus 15y is equal to minus 7. I'm going to double check. I should have 6x, 3y minus 1, 6x minus 15y minus 7. Okay, so there we go. So we have a couple options here. We can either multiply this by -1 and then get rid of the x's, or I can multiply this by 5 and get rid of the y's. Why don't we get rid of the x's? So go ahead and multiply this by -1 and then add straight down. Okay, so multiply this one by -1, this one by -1, this one by -1. You should be getting a fraction as an answer. Okay. So this is 6x plus 3y is equal to -1, minus 6x plus 15y is equal to 7. So we should have 18y is equal to 6. And when we divide both sides by 18, okay. Now, you can plug this into any equation that has two variables. So you can plug it into these, but you could also plug it into these. So I would plug it into something that doesn't have a fraction because it makes your life easier. So go ahead and work on this. Go ahead and work on that problem now. Right, don't plug it back into here. So now I have 6x plus 3 times 1/3 6x. Right? And the reason why is that this 3 will cancel out with that 3. And then we'll divide by 6. And then done. Okay. So there should be a decent number of you who are a little overwhelmed by this. We're gonna do it again because I know that fractions is something people struggle with in this class. Okay. So we're gonna do one more of these. Okay. If you're lost, ask questions. So go ahead and multiply each row by the lowest common denominator to get rid of the fractions. And if you're not sure what the lowest common denominator is, play this game. Okay, so go ahead and multiply each row by the lowest common denominator. Okay, so let's take a look at this. All right, so let's find the lowest common denominator of this one. 2 and 6. 2. 6 is equal to 2 times 3. So my lowest common denominator is 6. Now over here we have 3, 4, and 9. So 3 times 1 is 3. 4 is equal to 2 times 2. And then 9 is equal to 3 times 3. So this is missing 2 2s, 2 3s. So 9 times 6 is 36. All right. So what we're going to work on now is we're going to multiply everything in this row by 36 and everything in this row by 6. So over here, we're going to multiply everything in this row by 6. Where's my orange pen? We'll use this. Okay. And on the bottom, we're going to multiply everything by 36. And then we have now go ahead and do the division. 6 divided by 2, 6 divided by 6, 36 divided by 3, 36 divided by 4, and 36 divided by 9. See if you can get the next line. Let me put this y up here. So let's do this division. So now I end up with 3x plus 1y is equal to 1. And negative 12x plus 9y is equal to negative 4. Let me make sure I did that right. Negative 12, 9, negative 4. Yeah, that's great. So we can either get rid of the x's or we can get rid of the y's. I can multiply this row by -9 and get rid of this, or I can multiply this row by 4 and get rid of the x's. So I'm just going to multiply by 4, but you could have easily just multiplied this row by -9, and it would have worked also. So now you get 12x plus 4y is equal to 4, and negative 12x plus 9y is equal to -4. So I get 13y is equal to 0. And when I divide both things by 13, I get y is equal to 0.
Professor,
Go ahead.
where did you get the multiplication by 4, where you put 3x plus 1y equals 1?
This one over here?
Yes.
Oh, okay. So what I want to happen is I either want this to become a positive 12, so it cancels out with this, or I want this to be a -9, so it cancels out with this. See, my goal is to get to this line. Do you see how that's a 12 and that's a -12, so they cancel?
Oh, okay.
Okay, better?
Yeah, thank you.
Okay. So go ahead and plug this into either here or here, and then the problem will be done. So go ahead and give that a shot. Okay. So we have 3x plus y is equal to 1, y is equal to 0. So I get 3x plus 0 is equal to 1, 3x is equal to 1, x is equal to 1/3. So our answer is 1/3, 0. Okay. Now, if you're asking me, is there a good chance that this is on the quiz? There's a decent chance that this is on the quiz. I do like to give fractions on my exams. So something like this is absolutely fair game.
Professor,
Uh-huh.
so we don't have to plug it back into the original equation. We can plug it into the simplified.
Yeah, anything that has two variables. So all of these have two variables. So I would plug it in after we get rid of the fractions. So let's do this. It's 9 o'clock perfect. So let's take a 10-minute break and let's come back at 9:10 and then we'll start section 5.2. Okay. Okay, so let's get back to this. We're going to jump back to 5.2, and we're going to talk about negative exponents and exponents to the 0 power, things like that. Okay. Did anyone have questions on this before I erase it? Okay, so let's see.
Professor,
Go
I
ahead.
have a question. What we are doing, is it we solving by elimination or addition?
They're the same thing.
Oh, okay.
So some people will call it elimination, some people will call it addition. It depends on the book. I call it addition only because it's easier for me to spell addition than elimination. But people use it both ways.
Thank you.
Okay, so let's keep going. Okay, so yesterday we sort of introduced this sort of weird concept. We said, first of all, anything to the 0 power is equal to 1. Now, if you go, I don't understand why it's not equal to, why it's equal to 1. Why isn't it equal to 0? It's not obvious. Back in the day, people used to think, it's equal to 0. And at some point, someone came up and said, it's not equal to 0. It's equal to 1, and let me show you why. And somehow, he was able to change everyone's mind. So I'm going to show you what that is.
Is this 5.1 now?
It's 5.2.
5.2. Okay.
Yeah. So 5.1 is the one we did yesterday where we go, what's a polynomial? What's the degree? Okay. So if you go, I don't get why that's 1, we're going to show you in a second. If you go, that's not very intuitive, you're right, it's not intuitive. Most of the great mathematicians thought that was equal to 0. Okay. Now, then we went on to this new concept of a negative exponent. And we said that when you have a negative exponent, that means that you have to change levels. And when I change levels, it becomes positive.
Some genius.
Yep. Some genius told people, no, that's equal to 1, and was able to convince people. Okay, so the question is, how do you make that argument? All right, so we have two concepts here, 5 to the 0, and then this negative exponent means change level, and then change level, and then you can only evaluate something when it has a positive exponent. Now, in this class, you're only allowed to use positive exponents in your answer. So whenever you move things around, you're not allowed to have this as an answer. You have to convert it to this. You're not allowed to have negative exponents. Now, that is only in this class. If you go to NASA and you give them this as an answer, they'll go, cool, that's cool. If you go into calculus and you give people this answer, depends on your teacher. For me, I would look at that and go, anything that NASA accepts, I accept. So if you gave me that as an answer, I'd go like, yeah, cool, that's right. So we're only having this rule where you're not allowed to have a negative exponent just in this class, so you get used to manipulating it. Okay. Now,
Professor,
go ahead.
I have a quick question.
Sure.
What sections are we going to go through today?
We're going to go through, let's see, we did 4.3, 5.2. I probably will finish 5.2, and then we may start 5.3 just barely.
Okay, thank you.
Okay, no problem. Okay, because 5.2 is kind of a monster section. In a lot of books, this is 3 sections, and we just put everything into 1 section. Okay, so let's talk about this. Where did 0, where did this negative exponent come from? Okay, now, none of this is on the test, so you don't have to write it down. You can just sit back and watch. Okay. Now, let me explain how genius works. Okay, I'm not a genius. I can follow what genius people do and go like, oh, that's pretty cool. That was a pretty cool move. But what genius is you're looking for a pattern in a way that anyone previous has not thought of that pattern. So let's start with something that we recognize. 2 to the 1 is equal to 2. 2 to the 2 is equal to 4. 2 to the 3 is equal to 8, right? 2 times 2 times 2 is 8. Okay. Now, a normal person works like this. Okay, when I go in this direction, I'm going 1, 2, 3. When I'm going from the bottom, I'm multiplying by 2. 2 times 2 is 4. 2 times 4 is 8. Then I would get 16, 32, 64, 128. Okay. Now, what genius does is says, I wonder if I follow this pattern in a direction that people have not done before. Let me go backwards. 3, 2, 1, 0. Okay, so that's just my following this pattern backwards. Okay. Now let's follow the bottom pattern backwards. Okay. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 2. I'm sorry, 1/2. Right? 1 divided by 2. 1 divided by 2. 1 divided by, I'm sorry, 1/2 of 1/2 is 1/4. So if you go, why is this equal to 1? Oh, you just follow the pattern. Why is this equal to 1/2? We're just following the pattern. All right, let's create a new pattern. 1 over 2 squared is equal to 1/4. 1 over 2 to the 1 is equal to 1/2. Right? 1 over 2 to the 0 is equal to 1. And let's keep going. 1 over 2 to the minus 1. 1 over 2 to the minus 2. 1 over 2 to the minus 3. So let's look at these patterns. We're saying 2 to the negative 2 is equal to 1 over 2 squared. And we're saying over here, 1 over 2 to the negative 2 is equal to 2 squared. Now, if you were to just look at this right here and go, how would you describe what's happening? I'm in the numerator, and then when I go to the denominator, I become positive. I change sign. When I'm in the denominator, I go into the numerator, I just change sign. So when you change levels from numerator to denominator, you change the sign of the exponent. So that's how it worked. Now, I don't use the word genius lightly. I've met very, very, very few geniuses in my life. Very few. I got a PhD, I got a master's, I went to UCLA, went to law schools, I did research, and you go like, how many geniuses have you met in your life? I don't know, maybe 4? It's rare. It's rare. Most people just are good at studying a lot to the point where you start recognizing patterns, and then you're good at copying patterns. But a real genius will say, can I look at the world a little bit differently in the way which is completely unique from what's happened before? Okay. All right, so let's move forward. So a genius isn't someone who just gets good grades. A genius isn't a person who just studies. A genius is a person where something just kind of makes sense in a way that doesn't have. And if you ever worked with a genius, oh my goodness, what happened? There we go. If you ever worked with a genius, they just never finished. Now I hear about Leonardo da Vinci where he keeps working on the Mona Lisa because it's just never done. It's never done. It's never done. There's always something to do to make it better. You keep looking at it, it's not quite right until finally you just pull it away from him and just go like, I need it. I bought this, I need it, you gotta give me, right? And when you work with sort of a genius in math or in science, that's what it's like, where you're working on a thing and you solve something and then they just have another 10 questions. Like, we're just not done yet. There's so many more things that we can do. And if you can ever work with someone like that, it's exciting. Okay. I've done it. Only once in my life where I really worked with a pure genius. And man, it was exciting just to talk to that guy. Okay, so let's look at section 5.2. And we're going to say properties of exponents. Okay, so let's talk about the word property. What the heck does a property mean? Okay. Now, the way we use words in math is different from how we use words in other scientific disciplines. So in math, a definition has to be universally agreed upon. And it has to be an obvious yes or no. So in mathematics, we don't argue about definitions. If you look at other disciplines, like let's say science or sociology or psychology, where the fight is at is in the definition. So if I say, who's a girl? Well, it depends. Am I in Iran? Am I in Russia? Am I in Birmingham? Or I'm in LA? Or am I in San Francisco? Right? So the definition of who's a girl is being fought over. Right? So I am a progressive. I feel you are who you think you are. Right? It's sort of self-determination, how you self-identify. But if you went to Iran, they would say, I don't care. They would check your pants. Now, we can do that about any controversial topic. If I go, what's pornography? If I show a nipple in a movie, when is it pornography? When is it art? When we talk about abortion, when does the life start? Is it when you can hook it up the fetus to a machine and it lives, or is it a certain amount of weeks after conception? And then how do we know when it's conception? Because you don't actually know the day where it actually was conceived. So in terms of any sort of controversial thing that we have an argument over, normally we're trying to fight over a definition. In mathematics, we don't fight over a definition. The definition has to be something that anyone can look at and go yes and no, whether I agree with the concept or not. It's just a yes or no answer. So if you were to say in terms of gender, how you self-identify, it doesn't work. If you show a picture of me, you don't know my gender, right? You can't determine the gender. If you found a corpse, unless you need cognizance. If someone is sleeping and you ask for gender, you can't get it because they're sleeping. They can't tell me. So in terms of math, we couldn't use something like self-identification because even though I may believe that, it's not an obvious yes or no, depending on the circumstance. So in terms of mathematics, you would have to have something that is like a yes or no test. So let's just say, do you have a Y chromosome? Right? So we take a blood test, and then we absolutely know yes or no because we just look for something that is a yes or no thing. Okay. Now, because definitions are yes and no and universally agreed upon in mathematics, we have what's called properties. Properties are what is obvious. Right? Obvious. Now, in terms of, so normally what happens is because our definitions are a yes and no, we don't fight over a definition. It's a yes or no answer. We can then have things that we assume. So if we say only women can have a baby, well, it depends on where you're asking the question. If I'm in Russia where they don't accept gay people at all, it'd be no. If you were in Birmingham, it'd be, I don't know, depends. If you're in LA, absolutely not true, right? If you're in LA or San Francisco and you believe in it's how you self-identify, then no. So the problem with, so in math, what we want are our properties to be universal. Because this is not, because this is a simple yes or no answer based on a test, we can have things that we assume. Whereas if we were to talk about other things like abortion or gender, things like that, we can't make an assumption. It depends on who my audience is. Okay. So because we have firm definitions, we have things we can absolutely assume. Okay. Now, what a theorem is something that's not obvious. This is where our fights are. We say if we assume this and we assume this, these are things that we assume. What can we then deduce from that that's not obvious? Okay, and that's what a theorem is. In terms of social science, this is where you fight, right? If I can tell you, if I can change the definition of when does humanity start? When is a person? That has all kind of ramifications in terms of murder, in terms of abortion, in terms of contraception, and so on and so forth. Okay, so what we're learning here is properties of exponents. They're not things I have to prove. They're things that are so obvious that people go, yeah, that's right. I agree because seems right, seems obvious. Okay. Now, so let's talk about properties. Okay. So let's go through the properties of exponents. X to the, I'm going to put numbers here so it's easier for you to see. Okay. So the idea here is that I have 2 x's and I have 3 x's. How many x's do I have? I have 5 x's. So then the next question is, okay, Dr. Kawai, give me an example of that in a problem. So I would give you something like this. Now, everything here is separated by a multiplication. So even though it's not there, it's there. So whenever you have a multiplication, it doesn't really matter which order you do these things in. This is going to give me 24, and this is going to give me 24. So what I can do is drop the parentheses and move things that are similar to each other next to each other. Okay. Now, 5 times 2 is equal to 10. None of that has changed. We're not using any exponent rules here. All we're doing is multiplying the numbers. 5 times 2 is 10. Now I've got 2 of these and I've got 4 of them. And when I put them together, I should get that. I got 3 of these and I got 9 of those. When I combine them together, I should get this. So you get 10x to the 6, y to the 12. So let's try a new one. Okay, let's go. An exponent of an exponent turns into a multiplication. All right, so let's think about that one. When you have an exponent of an exponent, what you want to do is a multiply. Now, the reason why is what this is saying is I need 3 of these. And then in each one of these, there's 2 of these. I have actually 6 x's there. So whenever you have an exponent of an exponent, you need to multiply. Now I'm going to pair that with another one that's used with it often. So I'm going to have xy squared is equal to x squared, y squared. So go ahead and copy that, and then we'll do an example. Okay, so let's look at this problem. Let's look at simplify. So let me give you something that looks like this. Okay, now we're going to do a combination of these two things. Now this is the way I want you to see it. Even though it's not there, that 5 has an exponent. So even though it's not there, it's there. And what you're going to do here on the next move is you're going to multiply this by each exponent. Well, I don't even need that anyway. Right? 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. Okay. And then all you would do is just 25. Okay. Okay. So let me give you one to try. Okay, try that one. Now, what's going on here is very subtle. It's really important that you watch for that -2. See, this is normally what happens. When you have a negative number there, you have to make sure that when you distribute it, that square goes over here. Okay? So be very careful. What's really going on, maybe I should write one extra line, right? On a micro level, is that each one of these gets separated with its own parentheses. So if this is negative, this will turn into a +4, like that. So this is real subtle. So if that's negative, just be really careful. If that's even, then you'll get a positive number. Okay, now. All right, let's do the next one, 4. Okay. All right, now. So let's say I gave you something that looks like this. Okay, so let's say I gave you something like that. Now, what you want to do is you want to look at this as 3 separate problems. Okay. So if you're to simplify this, just like it's a regular fraction, right? Pretend like this is an algebra class, but a pre-algebra class. 2 divides into 8 and 6, so then that would turn into a 4/3. Okay. And then what you're looking at is the top number minus the bottom number. And over here, the top number, and even though it's not there, there's a 1 there. So you should have 4/3 x cubed y squared. Okay, so let's try this again. Let's try 10 over 15. So this one should be, I can divide both of those by 5. Oh, sorry. Now, for some of you, you didn't make this move. You just noticed that these y's were exactly the same and you cancel them and you'll go, does that work? And absolutely that works. So if we just cancel it and just ignore this, that's fine. But let me show you where that leads to. And then y to the 0 is equal to 1. And 2 times 1 is 2. But if you just canceled it because they're the same, that works also. It's a lot easier. Now, after this, we have all of our favorites. We have x to the 0 is equal to 1, and we have x to the negative 2 is equal 1 over x squared. Okay. All right, now, before we hit the negative exponents, because usually when we go 1 through 4 and keep everything positive, people are generally pretty happy. So let's look at a couple things before we hit the negatives. Now, if I give you something that looks like this, this is a variable. Oh, sorry. Well, yeah, let's just do it. Now, if I give you something like that, you might freak out a little bit, but let me sort of give you something that's very similar. Okay. Now, when you have this situation, you do an addition. Let's go copy that. So we can use the same idea here. When the base is the same and we're doing a multiply, we can just add the exponents. Okay. So these rules don't just work for numbers, they also work for variables. So let's give you two different problems. Do that one. And then let's make these an A. So go ahead and try doing those. So this is x to the 7 minus 3. So we're going top minus bottom. So that turns into x to the 4. And over here, we get the same thing. X to the 7a minus 3a is equal x to the 4a.
Professor,
Go ahead.
what is having the A there? Is that just an example that it's the same no matter what? When you're multiplying?
Just means that when you start getting harder classes, this will actually be a variable. And then in order to know what the actual value is, you'll go x is equal to 3, a is equal to 9, and then you'll plug it in and then you'll calculate something.
Okay.
So it's possible to have a variable in the exponent also.
Okay.
Okay, then let's make one more point before we go to negatives. Now, you are used to when we give you a problem that has a mixture of operators. Let's see, 5 plus 2 times 3. We have what's called the order of operations. Do multiplication before you do addition. Now, the nice thing about exponent properties is that there's no order. You're allowed to do this in any order that you want. So you can do this one or you can do this one first. It doesn't matter. You'll get exactly the same answer as long as you did it correctly. So, for example, if I give you these two problems, x3 over x4. Okay, now let me write it on this side also. Actually, let me make this one a 4. Then let me make this one a 3. It'll make it the example better. Okay. Now, in this side, we'll do this one first. On this side, we'll do this one first. And you'll see that you get exactly the same answer. So as long as you apply it correctly, it doesn't matter which one you do first, you do the one that you like, right? The one that you know that you can execute correctly. Okay. So this over here turns into x squared, x4 minus 3, top minus bottom. Okay. Now on this one turns into x6, and then top minus bottom, and you'll see that we'll get the exact same answer. So it doesn't matter which property you do first. None of them have a priority over the other. You just have to apply it correctly. Okay, so go ahead, copy that, and then now we're going to play around with negative exponents. Okay. Now, the rule is you're not allowed to have negative exponents in your answer. Okay, only for this class. So anytime we have a negative exponent, we got to make it positive. So let me give you a problem that you've done before, similar to this. Except this time, I'm going to give you some negative exponents. that negative. Okay. Let me put the negatives in red so we see the difference. So we'll make this one negative. We'll make that one negative. So go ahead and do this. Do the 2 times 3, then multiply the x's, and then multiply the y's. Excuse me. Now, most people won't do as many lines as I do. It's just for people where this is new. I just want to make sure that you know where I got each thing. I'm sorry. X squared, x4, y1, y to the 7. So 2 times 3 is 6. That's just a regular multiplication. But on the exponent level, we are adding them. Okay. Okay, now a lot of people will just go straight from here to here. And if you went straight from here to here, God bless you. I'm glad you can do it. Go ahead and continue doing it. For those people where you're like, okay, what am I supposed to do? Drop the parentheses and put the things that are next to each other, that are similar to each other, next to each other. Numbers next to numbers, x's next to x's, y's next to y's. Multiply your numbers, add your exponents. Now, do the same thing over here. Right? Drop the parentheses and put the things that are next to each other, that are similar to each other, next to each other. So we have 2 times 3, x to the negative 2, x to the 4, y to the 1, y to the negative 7. So we're going to multiply this. And then we're going to do an addition. Negative 2 plus 4. And then y to the 1 plus negative 7. So now you'll get 6x squared y to the negative 6. Now remember, no negative exponents. So then we have to change levels. Okay, so let's try another problem. So that's a pretty, this one over here is pretty typical of what I like to put on the test. That's probably something you'll see again. Okay, let's try another one. So let's try this. Okay, so let's try doing division with exponents. And then you know what? Let me also make this a -5. So it's a better example. So put a -5 there, okay, just to make sure. Okay. Now I'm going to teach it one way, and what I'd like to do is just show one way of doing something over and over and over that has the fewest number of rules. Now, some people will do it a different way. So I'll show you how that different way is, but this is how I'm going to do it from now on, only so people whom this is new to, they don't get confused by the different techniques, okay? So I'm going to do it the way I'm normally going to teach it, and then I'm going to show it the way that other people may do it, and then I'm going to consistently do it the first way. Okay. Now, what I want to do is think of this as 3 separate problems. So 10 divided by 2 is 5. And whenever we have a division, we do the top number minus the bottom number. Okay. Again, the top number minus the bottom number. Okay, let me give everyone a chance to copy and to like stare at that. So if they have a question, they can ask you. You're doing the top number minus the bottom number. Okay. Top number minus the bottom number. And then this becomes 5 to the minus 9. X to the, right, minus becomes a plus. Oops. X to the minus 9. Y to the minus 2, like that. And then we have to remember that we're not allowed to have negative exponents. Like that.
Professor, should be a y minus 3, right?
Oh, I'm sorry. Thank you. You're right. Okay. Now, let me show you the way that someone else may attack this. So let me erase this. Let me give people a chance to copy, but I'm just going to copy the same exact problem next to it. Okay. Because usually I get a question and then someone tries to explain it. And it's just easy for me to say, are you doing this? And go ahead and do that because that works. me attack it a different way. Now, for me, I always do it this way because I have one rule. Top number minus the bottom number. It doesn't matter whether it's a negative or a positive, always top number minus the bottom number. And if you ask me, well, why do you teach it that way? Well, it's one rule, and I can always just keep repeating it. Now, what other people will do is their teacher will tell them, hey, what I want you to do is get rid of all the negative exponents because that's what makes this problem hard. So you go 10 divided by 2 is 5. And I'm going to bring this 2 down because it's a negative exponent. Now, I'm going to flip these two places. The reason why is that that's negative, and then that's positive. Let me get a chance for people to catch up. Right? So all I did here was get rid of negative exponents, so everything's a positive. Now you have the situation where you go, well, that's a multiplication. I got 9 of those. Now over here, you ask yourself, do I have more y's in the denominator or in the numerator? I have more y's in the denominator. And you go, how many more y's? 3 more y's. So if you were to ask me which way is more correct, neither. If you ask me which way is faster, neither. If you ask me which way do most people teach it, half of them teach it this way, half of them teach it this way. I just teach it this way because it's easy to say top number minus bottom number. It's hard to like explain this to people where you go, how many more y's are there on the bottom? There's 3 more y's. But for some people, it just clicks better that way. So it's up to you to pick which one. I'm going to be consistently doing this one.
Professor,
Uh-huh.
the equation to the right, can you explain again how you went from y2 over y5 to y3 just at the bottom?
Yeah. What you ask yourself is, are there more y's on top or on the bottom? Right? Because technically what's going on is I have 2 y's on top and I have 3 y's on 5 y's on the bottom. These will cancel, and so I have 3 extra y's on the bottom.
Okay, thank you.
Yeah. So you can just go 5 minus 2, but it's on the bottom because there's more on the bottom. Okay, so we've got about another hour to go on this section, and luckily we got about another hour left in this class. So we'll do a bunch more of these because if this is new to you, this is one of the sections that really just sucks. It just really does. So let's come back at 10:25, and then go ahead and stare at that. And if you have questions, let me know, and then we'll keep doing more of these. But you should be unhappy. This is something where you really got to struggle with homework to get. Okay, let's get back to this. Did anyone have questions on what we just did? Because it's not very fun. Okay, so let's try another one just like this one. Because usually people have questions when they try it themselves. So let's exclude x. Okay, good. So let's do this problem. Oops. Let's go 12. Then let's go 13. All right. Try that problem. Okay, so treat these like 3 separate problems. So you'll have a 2 on the bottom. Then we have x10 minus a -4, and then we have y13, I'm sorry, y to the -1 minus 13, right? Top minus bottom. So then this will become x to the 14, y to the -14 over 2, and then x to the 14 over 2, y to the 14. Okay, so that's this. Okay. Now let's do something like this one. Okay, so go ahead and multiply all of these. Multiply the 2 and the -3, the 3 and the 5, and the -1 and the 8. And then see if you can finish it up. So I get x to the negative 6, x to the 15 over x to the 9. Now you can either add these or subtract these. Doesn't matter. I would probably add them first, but either way works. So this is x to the negative 6 plus 15. Like that.
Professor,
Go
I
ahead.
have a question for the bottom.
Sure.
Shouldn't it be a x to the 8 instead of to the 9? Multiplying it,
X.
right? Not adding it.
Which one? Over here?
Or like
Or on the right?
it's the one you're doing
Oh,
right
you're
now.
right. You're right. It's an 8. Thank you.
Okay, thank you.
Thanks for catching that for me. Okay. So now we have x to the 9 over x to the 8. And this is equal to x to the 9 minus 8 is equal to x to the 1, which is equal to x. Okay, let's try maybe 2 or 3 more, and then we'll move on to the last part of this section. So like I said, this is a real big section. It's usually covered by 2 or 3 sections on most books. Okay, so let's figure out how to do fractions. Okay, now, even though it's not here, the 2 and the 3 have an exponent. So you're going to multiply this negative 3 by each of these exponents. Okay, so see if you can do that now. Okay, so you'll change levels and make the 3's positive. So you'll change levels for both the numerator and the denominator, and then you'll figure out what 2 to the 3 is, and figure out what 3 to the 3 is. Okay, so I'll change levels, and when I change levels, I'll make the exponents positive. So we get 3 times 3 times 3 over 2 times 2 times 2. 9 times 3 is 27, and 4 times 2 is 8. Let's see, is there any other of these I didn't cover? No, I think that's it. I think I've covered everything. Okay. All right, now, if we have time, we may do a few more of these, but let's make sure I have enough time to finish the last part of this section. Okay, so this is still section 5.2, and what we're going to cover now is scientific notation. For those of you who are taking this only because you want to do business calc, and you're actually not taking it for a class, you're just sort of sitting in and listening, scientific notation is something you could skip. But for the rest of you who are taking this for a grade, it's on the test. Okay. Now, Google. Now, Google then is not a unique word. So the company Google was trying to find a cool little word to market itself by, and they came up with a Google, right? So where do they steal this name from? What the hell is a Google? A Google is a 1 followed by a million zeros. It's used to measure the distance between stars. So the problem with dealing in Googles is who wants to line up a million zeros, right? If I told you, okay, give me 2 Google, and you go like 2, and you're like, I'll be back in a second, I have to write a million zeros. And I go, subtract
Professor.
90. Go ahead.
Isn't a Google 100 zeros?
I think it's a million. Let me look it up. I think it's a million. Let's see. Oh, you're right. It's 100 zeros. My bad. Thank you. Okay. It's 100 zeros. I've been telling my class a million for the last 9 years. So there's 9 years of people telling their children the wrong thing. Okay. All right. Now, a Google is a 1 followed by 100 zeros. So I've said, hey, what's a Google times a Google? You go, wait a second, I've got to write out all these zeros. And all of a sudden, that just gets to be a pain in the butt. So we want a way to talk about really big numbers and really small numbers without having to write a lot of zeros and line up 100 columns. Okay. That's where scientific notation comes from. And let me, oops. Let me erase this too. So let's look at the basic rules for scientific notation. For those of you who are nurses, this is on the nursing T's exam, so make sure you can do this. Okay. All right. So scientific notation. So the key is that you have something that looks like this in this format. Now the rules for this format is that you can have only one non-zero digit in front. It can't be a 13 and it can't be a 0. So this has to be one non-zero digit in front, right? Meaning that that number has to be 129. You can't have 13, you can't have 21, you can't have 0. Okay. And the exponent is an integer, meaning that it's -2, -1, 0, 1, 2, and so on down the line. Okay, so those are my guiding principles. Now there's 2 more things that I want to sort of remember. If the exponent is negative, then the number is smaller than 1. if exponent is negative, the number is smaller than 1. The reason why is that because that's a negative exponent, I have to change levels. And if I divide something by a very big number, it's going to be less than 1. Now, if I have 3.14 times, if this is a positive exponent, this number represented will be bigger than 1. Meaning that I get 3.14 times 1,000. Okay, so go ahead and copy that. Then we'll do some problems. So let's look at this. So if I write convert, 342.7 to scientific notation. Let's just abbreviate that. Now, the way the game works is that I am forced to have my beginning part looks like this. Meaning that I have to have one non-zero digit here. This has to be 1 through 9. It cannot be 0. It cannot be bigger than 9. Right? So it has to be a number between 1 through 9, which is 3. So my decimal is going to get moved 2 places. Okay, so 2 places. Right? I move my decimal 2 places. So this becomes 2, and this is positive because this is bigger than 1. Right? The number we're starting with is bigger than 1, which is why this is positive. Okay, so let's give you another one to try. Okay, so go ahead and do that one. Okay, now remember, when you're doing homework, if you do homework only once, you're probably going to flunk. Any problem that you struggle with after you finish homework once, you do over and over and over until you have fluidity. Normally, if you haven't conquered a topic, it takes you to do a problem 5 times for it to be in long-term memory. So for some of you who are getting frustrated where you're doing the homework once and then you're taking the test and you're not passing, just know that, oh, you're going to have to do way more than once. So the reason why I wait till Sunday, 5 o'clock for you to take the test is I want you to spend all that weekend repeating the problems that you have the most problem with. Okay? Just repeating them over and over, just asking for new question, new question, new question. So let's move it 1, 2, 3, 4. So we move 4 places. So we have 1.098217 times 10. And all we have to do is figure out what number we put in there. So we definitely are going to put a 4 because we had to move this decimal 4 places. And since the original number is bigger than 1, it's going to be a positive. So let's give you an example of something that's going to be a negative. Okay. So this is going to be 2.3 times, oops, let me do a different color. This will be 2.3 times 10 to something. And you go, well, what did I put in there? I'm going to move it 3 places. Well, I'm sorry. I'm going to move the decimal 1, 2, 3 places. So that's going to be a 3. And then this is negative because the number is smaller than 1. So you'll probably get one problem where you convert it from a regular number to scientific notation. And then now what we're going to do is we're going to go the other direction. Okay, so go and copy that first, and then we'll go the other direction. And actually, maybe while you're copying, I'm going to run to the restroom. I'm going to be right back. Oh, sorry about that. Okay, now let's go the other direction. We're going to go from decimal notation to scientific notation. I'm sorry, from scientific notation to decimal notation. So we're going to go the other direction. So what a lot of people do, even though I tell them not to, they go, okay, when this is, I'm moving to the left, so it's positive. I'm moving to the right, so it's negative. Now, when we go the other direction, this gets flipped. So don't think of this in terms of left is positive, right is negative, because it'll be the opposite when we convert in the other direction. Think that if this decimal number is bigger than 1, positive. If this is less than 1, negative. Okay, that's how you want to think about it. Okay, so let's clear the decks. And let's go convert 2.35 times 10 to the 3 to decimal. Okay. So actually, let me get that here. Let me write that in a different color. Now, what you're doing here is I'm moving this 3 places, but when I finish it, this number has to get bigger. See, because we're multiplying by something big and positive. So I'm going to move this 3 places. If I run out of digits, I'll add in 0. So that's going to be equal to 2350. Well, that's a, I won't put the comma there. You'll think it's a decimal. Okay. So that positive over here means that we're making this into a bigger number because we're doing a multiplication. So go ahead, try this again. So we have 1.4, and then we have to move it in a way in which it gets bigger. 1, 2, 3, 4. I'm missing digits, so I'm going to pad that with zeros. So I'm going to get 14,000. Now let's try one last one. Okay. So now we have this situation where you have a negative exponent, so we're dividing by a very big number. So this number should get smaller. It should be smaller than 1 by the time you finish. So when you move your decimal, you're moving it to the left. So go ahead and give that one a shot. Okay. So you get 3.7. I'm sorry, let me do a different color. 3.7. Since that's negative, this number that we finished with has to be smaller than 1. So we're going to move it this way. 1, 2, 3. That's where my decimal goes, and then I have 2 zeros. So this turns into 0.0037, and we're done. Okay. Okay, now let's look at how to multiply and divide. Scientific notation. In terms of the XYZ, they have only very straightforward questions, which I'm happy for. I usually cover only the very straightforward questions. When you get into chemistry, they will spend a lot of time on multiplying, dividing, and sort of dealing with significant numbers and all of that jazz. I haven't taken chemistry since I was 15, so that was 37 years ago. So what we're going to do is just sort of the basic concept, and when you take your chemistry class, I'm going to let them explain it to you because they're much better at that than I am. Okay. So let's start with just a general concept that we know. So go ahead and simplify this. Okay, now, if you're staring at that and going, geez, I don't remember, I'll say, I don't blame you. We just did it, but then I just deprogrammed you and did other things. Well, let's take a look back at this. Everything here is separated by a multiplication. So things that are similar, we can put next to each other. So then I can give you 6x6 plus 5 x 11, like that. Okay. All right, so we did that. Now, even though if you didn't remember how to do it, hopefully that looks familiar. Now, let's change this into a scientific notation problem. Now, this x and that x, that's a multiply. These are not variables. These are multiply. Okay?
What happens to the variables then?
There's no variables. So this is a completely different problem.
Oh, it's a different problem. Okay.
Yeah. Let me write it like that. Okay. So we're going to use the same technique that we did up here. Okay. So this is a new problem. The only difference between this problem and this problem is before we didn't explicitly write the multiply as an x because then it would get confusing. But there is sort of this implied multiplication in between. 2 times something to the 6th power, 3 times something to the 6th power. Okay? 2 times something to the 6th power, 3 times something to the 5th power. This and this will use the same technique. So since everything is separated by multiplication, the things that are similar, you can put next to each other. So I just want to make note, these two things multiply, not a variable. So now you should get 6 times 10, 6 plus 5. This multiply comes from this over here, right? There's a multiply there. This is a times, not an x. Right? So you get the same answer. 6 times something to the 11th power. Okay. Now, I think in the homework, they give you a negative exponent. So let's do that. So I'll do a 1.0 to the negative 4, and we'll go negative 7 times 10 to the, let's make it 2. So what you should have is 1.0 times negative 7.0 times 10 to the negative 4, 10 squared. So a positive times a negative is a negative number. And then 10 to the negative, I'm sorry. And then you should be done. Okay. Now let's do division. Okay, so let's do something like 8x to the 6 over 2x to the negative 2. Let's try doing that problem. So in that case, those x's are variables. Okay, so treat these as 2 separate problems. So 8 divided by 2 is 4. And then you're doing the top minus the bottom. So then you're getting 4 to the x to the 8. Okay. Now let's do that with scientific notation. You're doing the same thing. So now treat these as two separate problems. 8 divided by 2 is 4. And then we're going 10 to the 6th, right? The top exponent minus the bottom exponent. And then we're done. Okay. Now, in your homework, there's a lot of little small problems. And what I want to do is, I went through them yesterday. I want to do them again because we have a little bit extra time. So I want to do a whole bunch of small problems from section 5.2, only because you're going to see it on the homework, and then I'm going to also put it on your exam. So they're quick and dirty problems I want to make sure you're comfortable with. Okay. So I'm going to put a whole bunch of small problems up here, and let's knock them all out. Okay, so this goes like this. Okay, so let's do a whole bunch of smalls. So let's go back to this. Okay, go ahead, walk your way through these. So let's do a few of them. Okay, so you can start to see the patterns. Now, that negative is not connected to the 3. That's -9. This one is -3 times -3 is equal to, a negative times negative is positive. Now this negative is not connected to the 3. So 3 to the 0 is 1, so that's -1. Okay, keep working yourself down. And there are going to be a lot of these on your homework. Now this 0 applies to everything, which is why that's 1. And over here, in between the -3 and the x, there's a multiplication. So these two things are separate. So you turn into a -3 times 1, which turns into a -3. Okay. Now work through these. Okay. Now you work down this one. So we're going to work on, so this looks like 1/3 squared, 1/3 times 3. That's -1/9. Now here, be careful. There's a multiplication there. Even though you can't see it, it's there. Let me move this over a little bit. So even though it's not there, it's there. So the exponent only goes to the x. So we change this level. Now, this one is confusing. This one has sort of 2 ways to attack it. So I'm going to show you 2 ways to attack this problem. One way is to say both of these have an exponent of 1. And there should be parentheses around both of these, and you're basically distributing that -2 to both of them. So this should turn into 1 over like that. And since there's a parentheses on the outside, I should get 1/9x squared. That's one way of attacking it. The other way of attacking this is we go, this is we bring the whole thing down, and then we make this positive. And then this turns into there's a parentheses there, so then we get 1 over minus 3 times minus 3. You get 1 over 9x squared. And since that 0 is on the outside, this thing just turns into 1. Okay, so go ahead and copy that. And then we're going to start on another section. We got 10 minutes, I'm going to use it all up. Unless someone has a question and stalls for time. Okay, go ahead and copy that. Okay, I'm going to start doing the intro for section 4.6. And it looks something like this.
What's the name of the section, Professor?
This is solving system, solving systems with 3 variables. Okay, now you don't have to copy what I'm writing. So you don't have to copy. Okay. I just want to show you what they look like, make sure everyone comes on time tomorrow, because this is one of those sections where if you come in late, it's just, you're done, right? Last semester I had someone come in 10 minutes late and they looked at the board and they went, oh crap. Okay, what the hell is this, right? So again, don't copy, we're just going to talk about this. I got something with 3 variables, x, y, and z, and what does that mean? Okay, let's talk about what that means. This is the only place, This is the only place we're going to talk about the standard form of the line equation. Okay. So let's say I have 2 variables. What that is a line. So you go, okay, fine, I get that. That's in standard form, x, y, c. You go, okay, that's a line. And then the next question, what's the job of a line? The job of a line is to separate 2 sides of a plane. So when you're a kid and you share a desk with a girl, you go, that's my side, that's your side. And if your stuff comes on my side, I'm taking it. Well, it's usually the girls told the boys. We were told not to bully, so we were scared of the girls. Okay, at least at my school. Then you go, okay, I'm good with that. Well, how about if we have something like this? you'd say x is equal to 3. And then the teacher would say, well, graph 3 on the real number line. All right. You draw a number line, you draw a point, and you go, what's the job of that point? The job of that point is to divide the line into 2 pieces. This is everything smaller than 3, everything bigger than 3. Well, let's follow that pattern. Okay, 1 dimensions, 2 dimensions. What is 2 dimensions? Well, I'm sorry, 1 dimension, 2 dimension, 3 dimensions is like a cube. It's like what we walk around in. So this is the standard form of a line in 3 dimensions. You go like, what the hell does that mean? Well, what's the job of this point? To divide the space into 2 spaces. What's the job of that line? To divide this plane into 2 spaces. Well, what divides a 3-dimensional space? A wall. Right? So if I have a plane, well, that doesn't look very nice, but let's just pretend it did. Or it does. The job of this, or what this shape is, it's a plane. It's a wall that goes on forever. And the job of the wall is to divide my side of the universe with the other side of the universe. In this room, this board is my side of the universe. And on the other side is where my wife is. That's her side of the universe. We divide the universes into 2 places if I extend this chalkboard in all directions forever. And then you go, well, okay, what's 4-dimensional line? Well, I've run out of letters. Let's start the alphabet again. Usually the 4th dimension they say is time. So it is everything before this moment and then everything after this moment. So this moment here where I pause, that's my 4-dimensional line, right? Because if you think of this as an animation in 3D space, so everything before this moment and then everything after this moment. And we can just keep adding dimensions by adding variables. So then the next question is, okay, so I believe you. I believe that each one of these is a plane. So the question is, what does this solve? Well, let's think about it. Again, you don't have to write this down.
Professor,
Yeah, go ahead.
will this all be reviewed tomorrow?
Not the explanation. Tomorrow we're just going to solve the problem.
Oh, okay.
Okay. But this part where I'm just trying to give you this feel of some intuition of what the hell are we doing, that I won't repeat because it's not on the test. Okay. So if you think of this as each one of these as a wall, okay. So here's one plane. Here's another plane. And here's a third plane. Now, in the past, what we did when we had problems that looked like this, we said, oh, that's where 2 lines intersect. That's my solution. So if you're to ask me, hey, where does the orange, green, and blue plane intersect? In the corner. So what you're looking for is, here's a wall, here's a wall, here's a wall. Where's the corner where all 3 walls meet? And this basically becomes your solution. Okay. The solution is, where do these 3 planes meet? In the corner. And then that's what we're going to work on tomorrow. So these problems are big and long. So don't be late because if you miss the first 10 minutes, oh, pain. Okay? And it's definitely on the final, definitely on the midterm, definitely on the quiz. Okay, so I think we're 2 minutes early, so you guys are free. And if people have questions, go ahead and ask me questions.
Professor, thank you.
Oh, no problem. Thank you. Thanks, everyone. Thanks for hanging in there.
Thank you for class, Professor. Have a
No
good day.
problem. Hang in there. And then, Sandy, when you worked on your quiz, did you try the different browsers?
Yeah, I did. I was just gonna talk to you about that.
Okay.
The same issue where it's saying that my session is expired, and I screenshot it too. I can text it to you.
Yeah, could you can you email me that right now? What I want to do is I'm gonna screenshot it and I'm gonna email it to their IT and we'll see what they say. Now we could do one of two things. One, we could say, let's just skip the quiz and your grade will be the highest of the next two quizzes. If you go, oh no, Dr. Kwai, I'm really good at this. While we're waiting for the answer, what we can do is we can say, you tell me a time, I will email you the test. And then you take it for an hour and a half and you email it back to me.
I'm sorry, Professor, you kind of cut off. Can you repeat that to me?
Sure. So the first thing I want to do is I want to write an email to the IT and email me the error message that you got.
Okay.
And then you said you're using a Mac.
Yeah.
And then you've upgraded your software. You've upgraded your OS.
Yeah, I've upgraded everything, and then I'm doing the homework, so I don't know what the issue is.
Okay, and then you've used Chrome, and which browsers have you used?
I use Chrome, I use Firefox, I use Safari. I use the 3 different methods.
Okay, so what I want you to do is email me the error message.
Okay.
Okay. Okay, let me write down everything. So I'm gonna email them. Yeah, email me your error message, and then I will write the thing and CC it to them. Now, I'll give you 2 options. One is you skip the exam, and your quiz score is the higher of your last 2 quizzes. The other option is you tell me a time, and I will email you a written version of the exam.
Okay.
You just do it. I'll hand grade it, and you just email it back to me an hour and a half later. You can just take pictures of it, or if you have a scanner, you can scan it.
Okay.
So why don't you think about which one you want to do? I'll give you whatever choice. You just tell me the date and time. I email it. You take it. We'll give you 20 minutes to take pictures or scan it, and then email it back to me, and then I'll just grade it. Maybe we'll do that.
Okay, and how long is it? How long can I take the test for? The hour and a half that is usually on the.
Yeah, so we'll go 90 minutes to take the test, and then 20 minutes to email it back to me.
Okay. 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 I guess I'll think about it, and I'll let you know, and then I'll screenshot that to you.
Absolutely, and then just send it back to me, and we'll move forward with that.
Yeah, I'll send it to you after work 6, just because I have to go to work in an hour.
No problem. Yeah, let's do that, and then you tell me a time, and we'll do that. Okay.
Okay, perfect. Thank you.
Thank you.
Professor?
Uh-huh.
Oh, I sent you an email yesterday talking about one of the problems on XYZ homework.
Yeah. Did you figure out how to do it, or should we do it together?
Yeah. So the thing is, I knew how to do it. I just wanted to wait to tell you during the office hours. Just my problem was that, so for my y-intercept, I kept getting a 2.75. But
Wait, for which one? For the y, the minus 4x plus 11?
Yeah.
Okay, so let's do that one.
Okay.
So for that one, they want you to get whole numbers.
Mm-hmm.
So let's
or
take a look.
0.5, but
0.5, right? Yeah. So then you'll have to use something other than 0, 0. So let's look at that. So for I think it's 4x plus y is equal to 11. Okay.
Yeah.
So 4x plus y is equal to 11. Now, you could do one of two things. You can't do slope intercept because 11 is not in your grid, I think. So the other way you could do it is, since you have y by itself, you can put 0, 1, 2 in there. So if I get y is equal to minus 4x plus 11, and I plug in 0, I get 0 and 11, and that doesn't fit because 11 is not in your grid. Your grid only goes to 10. But if I put a 1 in here, minus 4 plus 11, I get 7,